and welcome to today's session on quadratic graphs. This is lesson 7 in my GCSE preparation course series, designed for helping Year 10s feel more confident and prepared for their GCSEs next year as they go into Year 11. We're looking at quadratic graphs today, and we're following on from the work we've done in the previous few sessions. So to start with, there's a question there to just check your understanding of the language used around graphs. So while we're waiting for a few people to log on, have a go at that starter question. Hi to those just joining us. We're just having a go at this starter question, or we're waiting for a few people to log on. If you have any questions at any point, just type in the chat box and I'll get back to you as soon as possible. These sessions are recorded in advance, but I am watching along live with you and here to answer any questions you've got, so I'll just type my answers in the chat box. Just a reminder that you can always download these slides as handouts before the session starts, so you can have a go at the questions in your own time, or if you prefer to have, for example, these graphs to write your answers onto, I find it a bit easier. So handouts are always ready, at least the night before the session, from my website, mrsk'slightbulbmoments.wordpress.com. Right, just one more minute on those starter questions. Have a go at the extension if you've finished. So I want to see if you can work out just from that graph the equation of that curve. Right, are we ready to have a look at this together? Super. Let's start with part I. So write down the coordinates of the Y-intercept. So the Y-intercept is where it crosses the y-axis, and that is this point on my curve. And as a coordinate, that would be 0 and then 2. Nice straightforward one there, just checking we know the language concerned. Okay, the next question. Use your graph to find the coordinates of the points where f of x equals 0. So written slightly differently here, f of x is the function and can generally be replaced with y, because often we have an equation like y equals something, and sometimes it can be written as f of x equals something. So y and f of x tend to mean the same thing. So here we're looking at where y equals 0. So that's the height being 0, and that is these 2 points on my curve, here and here. All right, it wants coordinates. As you're just reading from a graph, you can't be that accurate, but try and be as accurate as you can there. So I've got every little square is 0.2, so 2.2, 0.4, 0.6, and it's about halfway. So I would say that's 2.7. So my first coordinate I'm going to say is 2.7 and then 0. And my second coordinate is this negative one, minus 0.2, minus 0.4, minus 0.6, minus 0.7. so minus 0.70. Okay, so as accurate as you can be on there to get your coordinates. Now you could obviously find these if you had the equation, you could complete the square, you could use the formula to get the exact values, but in the question it said use your graph. So there's a little bit of a hint on the method to use, and you would have to show that you got it from the graph. So in an exam question, either draw those little crosses on to show where you've got it, or draw a little line of where you're reading from on the axis. Right, the last bit then was find the maximum or minimum. Now this has got a maximum point, and that's right up here. Okay, so my maximum, now it said the value of f of x. Now remember that's the value of y, so that is actually just 3. So my answer to that question is 3. If it had said find the coordinate of the maximum point, then we would have written 1, 3 as our coordinate. But it just said the value of f of x, so our answer is just 3 in this case. All right, so well done if we've got those. It's just again a quick recap of some of that graph terminology. If anyone tried the extension, I'm going to put the answer up there. So we should have got minus x squared plus 2x plus 2. So you could have had y equals that or f of x equals that. At the end of the session, you should be able to work that out. I'm not going to go through it now, but hopefully as I cover all the little topics within this lesson, you would be able to come and have a go at that question again and see why we get that answer. All right, if you've got any questions on that, do just type them in the chat box though, and I'll try and answer them, especially if you're still unclear by the end of the session. Right, let's get going then. So I'm going to start with completing the square because this is really important for helping us find maximum and minimum values. Then we're going to know actually how to use the completing the square, so on our graphs. And then we're going to look at some general formats of the quadratic equation graph and what we can spot from it, so finding roots and so on. So if you just read this little box on the left, completing the square allows us to rewrite a quadratic equation in a different format. This new format helps us solve challenging quadratics, find turning points, and sketch quadratic graphs. So that's a few of the reasons we will complete the square. We're just going to be focusing on rewriting it in that different format. So to start with, let's look at this example here. I'm just going to focus on putting it in the format of a completed square. Nothing to do with solving graphs yet. We'll just see if we can do this bit. Now, I'm going to show you what we do and then explain why, because I think it's a bit easier. So, our format is, we rewrite the first 2 terms of this equation as x minus 5 squared. Now can you see I divided both terms by x, so x squared just became x and the 10x, the x got taken off, and I've halved that second term, so rather than minus 10 it's now minus 5. It's all in brackets and it's squared. Now that's because if I actually wrote this out as 2 double brackets, x minus 5 times x minus 5, and expanded it, I would get x squared minus 5x minus 5x plus 25. Simplify it, x squared minus 10x plus 25. So look at those first 2 terms, x squared minus 10x, x squared minus 10x. So doing that, taking the x's off both of those terms and dividing that 10x by 2, gives us a bracket that when we expand it, we get those 2 terms. But you'll also notice we got plus 25 at the end here. And in our question, we wanted minus 1. So that means for my actual answer, I want that bracket I've just found, x minus 5 squared. But when I expanded that, it gave me 25. If I only want minus 1, I need to subtract 26. So that is the completed square version. We've got a square bracket, which is where the square part comes from, and then the minus 26 is you completing the square to make it the same as your original equation. Okay? I'm going to run through that reasoning once more and then you're going to have a go. So to start with, just look at those first 2 terms, divide them both by x and halve that middle one. So we get x minus 5 in brackets squared. Now you don't have to expand the brackets each time. I was just showing you how it got you down to x squared minus 10x. The only important bit is this number at the end. So to get that, we could have just done minus 5 squared. Minus 5 times minus 5 gives us 25. That's the bit that helps us complete the square, because we know that bracket would give us positive 25. We wanted minus 1, so that's why we write minus 26 after our bracket. All right, let's have one for you to have a go at, and I'll go through it once more on your one. So y equals x squared minus 8x plus 20. Okay, are we ready to go through it together? Let's see. So the first step was we write that out as x minus 4 squared, because we divide by x and we halve that middle term. Now imagine that double bracket, when expanded, that last number is going to be minus 4 times minus 4, which would be 16. I wanted 20, so I have to add 4. So that's just my answer, x minus 4 squared plus 4. All right, so you don't have to do that expanding the brackets every time. That's just me showing you where it came from. Just write it in this format and then work out how to complete the square. All right, we're going to move on to some slightly more challenging examples, but it will keep coming back to this same kind of skill. So don't worry if you're still a bit unsure about this. Completing the square is something that you just need a lot of practice on. So it's just about repetition. So there's a few questions I always get asked with these, and one of them is, what if there's an odd number of x? So I'm going to go through an example and then you're going to get a chance to have a go. So have a look at this one with me. We've got y equals x squared minus 5x plus 4. So if I'm going to put it into my normal brackets, I would write x, and then I have to do 5 divided by 2. Now you've got a choice here. You can either work with fractions or with decimals. I find fractions a lot easier. Now a lot of you will think, oh, decimals are easier, I don't have to deal with fractions. But actually the multiplication becomes a lot more difficult. So I would suggest using fractions, and we just have to write it as 5 over 2. So that's me halving that middle term, and we get 5 over 2. Now the tricky bit is I need to work out what that squared is. So I've got minus 5 over 2 times by minus 5 over 2. Now it's actually nice and easy with a fraction. Just multiply the tops. 5 times 5 is 25. 2 times 2 is 4. So that's what I get when I square 5 over 2. Now I've got to work out how to get that back to just plus 4. That's the bit that seems a bit confusing, but it's really simple if we make this a mixed number. 25 over 4 is the same as 6 1/4. Okay, 6 fours is 24. We've got 25. So now it's a bit easier. This bracket gives me 6 1/4. I want plus 4, so therefore I've got to take away 2 1/4. Can everyone see how that works? And that's my final answer. So you can just leave it in your fraction format. You could have done that with decimals. I'm just going to show you in case you really prefer to work with decimals. So in my brackets instead I would have x minus 2.5, so that's 5 divided by 2 squared. Then we'd have had to do 2.5 times 2.5. Now that's a little bit trickier. You can do it as 25 times 25. So we get 625, but then you have to know the decimal place is going to go there. So 2.5 times 2.5 is 6.25. Now you have to work out how to get back from that to 4, which was in our question. So I'd have to take away 2.25. So it's the same answer, it's just written in decimals rather than fractions. Completely up to you how you like to work, whether you like to work with decimals but do a bigger calculation, Remember, this could be a non-calculator paper, so are you happy doing 2.5 times 2.5, or would you rather work in the fractions there? Now for the rest of them, I'm going to continue to work in fractions, but if you wanted to work decimals, absolutely fine. Right, you have a go then at your question there. Y equals x squared plus 7x minus 5. Can you write that in completed square form? All right, should we have a look at this one together? So halve the middle term and we get x plus 7 over 2 squared. Then we have to work out that 7 over 2 times 7 over 2 gives me 49 over 4. I've got to work out how to get from 49 over 4 down to minus 5. So let's make this a mixed number. We've got 12 and a quarter, because 48 is 12 lots of 4. So how do we get from 12 and a quarter down to minus 5? We take away 17 and a quarter. And that's our final answer. Again, you could have done that as a decimal, and you'd have got x plus 3.5 all squared minus 17.25. Okay, are we happy with that? So if it's an odd number, choose fractions or decimals, but it works exactly the same. The next question I always get asked is, what if there is a number at the front? So just have a look at these two examples here. We've got y equals 2x squared minus 6x plus 7, and y equals 3x squared plus 6x minus 5. So the tricky bit here is the number at the front. Now it's very similar to what we do before, we just have to do one more thing. We've got to get rid of this 2 to start with, then we can do our normal format. So we start by just taking the 2 outside of brackets. Now I'm going to use square brackets, because in a minute I want my nice curvy brackets for my completed square. And if there's brackets within brackets, it tends to get a bit confusing, which is why we use square brackets as well. So it's like having a different symbol. So divide everything by 2 and we just get left with x squared minus 3x plus 7 over 2. Remember to divide that last bit by 2 as well. Can we see what I've done there? So just taking that 2 out. Now I'm going to pretend that 2 doesn't exist, and I'm just going to focus on this middle equation. Now we've still got to write that 2 so we don't forget it. So still write your 2 and your square brackets, but now just focus on the middle bit. We've got to complete the square for this equation. So getting that into our right format, we have x minus 3 over 2 squared. The most common mistake here is you forget to halve this because you think you've already halved it. But that original halving wasn't to do with completing the square. So this is here where we complete the square and we halve it. Now 3 over 2 times 3 over 2, let's just do that up over here out of the way. 3 over 2 squared will give me 9 over 4, which is the same as 2 and a quarter. Now, I've got to try and work out how to get back from that. Actually, I'm just going to get rid of that 2 and a quarter bit. Let's not do that step. Let's leave it as 9 over 4. I've got to work out how to get from 9 over 4 back to 7 over 2. Now, slightly tricky, but remember we can rewrite 7 over 2 is 14 over 4. So just make them a common denominator. So now, how do I get from 9 over 4 to 14 over 4? I add 5 over 4. Okay, and that is my square completed. Just take a minute to see what I've done there. So just like normal, 3 over 2, we squared it, we got 9 over 4. I had to get that somehow to 7 over 2, so we made that one over 4 so I could compare it. Now we haven't quite finished our question because we've still got this 2 outside our square brackets. So all we have to do now is multiply it back in. So 2 lots of this square bracket is just 2 and then the bracket squared. So we just write the 2 in front of that bracket for the first term. Okay, 2 times x minus 3 over 2 squared. Plus, now we've got to do 5 over 4 times by 2. That will get you 10 over 4, which is the same as 5 over 2. Okay, and that is my final answer there. Are we happy with that bit? So take the 2 out completely, complete the square on the equation inside, and then just put that 2 back in. Write it in front of the bracket, and then multiply that last term. Okay, have a practice then. Your question is y equals 3x squared plus 6x minus 5. Alright, should we start going through it? Don't worry if you haven't quite finished. So here we're going to take the 3 out. Use your square brackets. It just helps to know what stage you're at or what you've done. We end up with x squared plus 2x minus 5 over 3. All in our square brackets. Then we're going to complete the square on just that middle bit. So rather than x squared plus 2x, we have x plus 1 squared. Now that would give us 1 times 1, which is 1. I need to get down to minus 5 over 3. Now this might help if you think 1 is equivalent to 3 over 3. 3/3 make up a whole. So I've got to get from 3 over 3 to minus 5 over 3. So I've got to take away 8 over 3. Okay, again you could have that as mixed numbers, you could have it as decimals, either or. Now to finish the question we expand through by 3. So we end up with 3 lots of x plus 1 squared. And then minus 8 divided by 3 times by 3 is just minus 8. A nice simple one there to finish. Alright, happy with that? That's probably the trickiest they get with completing the square, is taking that number out and putting it back in. Well done if you're following so far. There is one more question that comes up and one slight difference with it. And that is, what if my x squared value is negative? So have a look at these two. We've got a minus x at the front. Now this is actually a lot simpler than a number being at the front, but we will use the same method. So if we have a go here, we're going to divide by minus 1. So it's basically taking minus 1 outside your brackets or just taking a negative sign out. So inside I'm now left with positive x squared minus 2x minus 2. So we've just ultimately changed all the signs. Keep that negative outside the square brackets, don't forget it. Now complete the square. X minus 1 squared. Minus 1 times minus 1 gives you positive 1. We need minus 2, so I take away 3. Okay, nice easy one there. Now to put the negative back in, we just do exactly what we do with the number. Write it in front of that bracket. Now minus 1 times minus 3 is positive 3. Just changes the sign. And that's your final answer. Okay? You'll go. Nice quick one. I'm giving you 20 seconds. Have a go. Right, that's your 20 seconds up. It's fast. Did you do it? Let's have a look. take your negative out, we end up with x squared minus 4x plus 2, close brackets. Now complete the square. X minus 2 squared. 2 squared or minus 2 squared gives you positive 4. We want positive 2, so take away 2. Put your negative back in and we end up with minus x minus 2 squared plus 2. Final answer. Well done if you got that. The tricky bit here, and with when you take a number out, is when I was doing this bracket, when I was completing the square, so I did minus 2 squared with positive 4, and I needed to get back to plus 2. A lot of people think we're getting back to this original, but remember we've changed it. We're getting back to what's inside our bracket. So don't look at the original once you've taken that negative out. Ignore that question. We've basically changed the question. Okay, right, well done. Now, there's some practice questions here. I'm not going to give you time to do these now, but if you need more practice on these, you can always come back to the video and pause it. Bronze is slightly easier, silver slightly more difficult, gold have the number in the front and some negatives there as well. Okay, so pause now if you're watching a second time and have a go. Answers are coming up. Right, those are the answers. Pause to mark your work. Okay, let's move on. Right, so we've done the basic completing the square. We know how to do that step. For the second part of our session, we're now going to look at these uses of completing the square. So we can solve quadratics, we can find turning points, and ultimately we can sketch our quadratic graph. So I'm going to show you all three things at once on this equation. So we're going to look at one bit solving first. Now I've already completed the square, so the question was y equals x squared plus 6x minus 5. We've completed the square to get y equals x plus 3 squared minus 14. Now solving, you have to set it equal to 0. So instead of y equals, we have got 0 equals x plus 3 squared minus 14. Okay. Now if you were rearranging this to solve, what would you do next? Yep, we add 14. Add 14 to both sides. We end up with that. What's your next step going to be? Square root both sides. So we get the square root of 14 equals x plus 3. Now we've got to remember, we've actually got to put a plus or a minus on this root 14. Because when you square root a number, it will have two solutions, a positive and a negative. Just like when you're doing the quadratic formula and we've got plus or minus, the square root of b squared minus 4ac, we've got two signs. So square root the 14, but write that plus and minus. Now, we've got to get x on its own, so I've just got to take away 3. So my left-hand side is plus minus root 14, take away 3, and it equals x. Now you might write that the other way around and have x equals minus 3 plus or minus root 14. Makes it a bit neater. Okay, but it's exactly the same answers. If you needed them to decimal places, for example, you can plug them into your calculator and we actually get x equals, so if I use the positive, so minus 3 plus root 14, I get 0.74. And if I use the negative, I get minus 6.74. Okay, and they're both to 2 decimal places. All right, so you can keep it in its third form, or you can plug it into your calculator and get a decimal version. So that's the same kind of thing you'd get if you factorised and flipped the signs, or if you used the formula and got your two answers. It's exactly the same. We're solving, we're finding those roots, but it's just a different method. We're using the completed the square. It's actually a lot easier than plugging it into the whole formula, especially if you've already got the square completed. Super. Now let's look at finding the turning points. Now here we're going to use the completed the square version. So I'm just rewriting our completed square. X plus 3 squared minus 14. Now the turning point here, this is a positive parabola. Look right back at the question. We've got positive x squared. So that means it's a nice U shape. If it was a negative x squared, it would be a sad face, upside down. But it's a nice U shape. So we know it's going to have a minimum point. So right at the bottom there, it's got a turning point, minimum point. Now, that means I need to find the smallest possible value of y. To get the smallest value inside this squared bracket, what if x was 0? 0 plus 3 is 3. Square it, we get 9. Okay, still quite high. Can we make it even smaller? What if x was minus 3? Minus 3 plus 3 is 0. Squared is 0. So is 0 the smallest I can get? What if x was minus 10? Minus 10 plus 3 is minus 7. But when we square minus 7, we'd get positive 49. So when you square something, it can never be negative. That means the smallest that bracket can be is 0. So the smallest y can be is 0 minus 14. So the smallest is minus 14. Now, to get the actual coordinate of that, what x value gave us 0 in that bracket? It was minus 3, wasn't it? Because minus 3 plus 3 gives us 0. Now, if x was minus 3 and we got 0, that meant y ended up being minus 14. And that's because 0 minus 14 is minus 14. Now that's why it works, that's the theoretical understanding, but a lot of people find that concept a little tricky to grasp. And there is an easy way to just write down the coordinate, even if you don't understand what's going on there. You'll see in this bracket we had a plus 3 and our coordinate is minus 3. You're used to flipping the signs when you find coordinates, like when you find your roots from a factorised form. If you had x plus 3, x plus 5, you'd have your solutions as minus 3, minus 5. So it's just the same. Flip the sign in the bracket to get the x value. Now the y value is just this last term, not flipped. Okay, so we keep that as minus 14. So a way to remember, straight from the completing the square point, if it's in the bracket, flip the sign. If it's out of the bracket, keep the sign. So we get minus 3, minus 14 as a turning point. Okay, let's put that all together into sketching our graph. Now, you can see that we're going to have roots at 0.74 and minus 6.74. Because that's when we solved it. Remember, when you solve it and you find your x values, those are the roots, that's the x-intercepts. So roughly minus 6.74, 0.74, something like that. They just have to be on the right side of the graph. What else can we put on? Look back at the very original equation up there. Y equals x squared plus 6x minus 5. Does that tell us anything about the graph? Firstly, it tells us it's a nice positive parabola because we've got positive x squared, but also we've got this minus 5, which is the plus c. So remember, we've got a y-intercept of minus 5. So I know that it's actually going to cross my graph down here at minus 5. So now I've got the x-intercept and the y-intercept. I've also worked out the turning point. We did that above. So that's at minus 3, minus 14. So minus 3, minus 14, somewhere down here. Now we've got to join them up in a nice parabola shape. Now mine's going to be a bit skew-if, but something like that would be fine. Make sure yours is a nice fluid curve when you've done it. A little hint is to work out roughly where they're going to be and draw your curve first, as long as you know what quadrants it's going to be. So it's important that you know whether it's on the negative part of the axis, the positive part of the axis. This turning point, for instance, had to be in the bottom left quadrant because it was minus 3, minus 14. Always, when you've done a sketch, write in your coordinates. I'm not going to do it on here, it's going to be far too small, far too messy for you to see what I've done. But when you do a sketch, you should write in the coordinates of any intercepts and your turning point if possible. Okay, are you ready to try one of those? So there's a lot in one go. You're going to have to solve, so remember set it equal to 0, find the turning points, and then sketch your graph. All right, have a go at this one. So I've already completed the square for you. The original equation was y equals x squared plus 4x minus 6. And the completed square version is y equals x plus 2 squared minus 10. Right, have a go. Solve, find the turning points and sketch. How are we doing? Should I have a little bit more time? Give you about 30 more seconds. Do you remember you can post in the chat box any questions you've got that I haven't gone over, and I'll get back to you. Right, let's have some answers. So I've typed these ones so it's easier for you to see. When solving, set it equal to 0, add your 10, square root, but remember to do the plus minus, and then your solution is minus 2 plus or minus root 10. If you plug that into your calculator, you get 1.16 or negative 5.16. Well done if you got those. Finding the turning point, you flip the number in the bracket, so we get minus 2, and you keep the sign outside the bracket. So it's minus 2 minus 10. Put all that together into your sketch and we should get this. So you've got your roots at minus 5.16 and plus 1.16. You've got your turning point down the bottom left at minus 2 minus 10. And you've got your intercept at 0 minus 6. It's really important to remember the intercept comes from the original equation, that minus 6, not that number there. And that's because we also get a number from this. We'd get 2 squared, so that's 4, minus 10, which gives us minus 6. So it's much easier to spot in the original equation. Okay, well done on that. That's pretty much the trickiest stuff with completing the square and its application. So you're putting it into a graph format, you're using it to find turning points and to solve equations. Okay, really good work there. I'd like you just to look at one or two of these questions. So this is testing your knowledge of using the format here. So we've got question 1 gives you y equals x plus 3 squared minus 2. And you've got to work out on the graph, can you see we've got the turning point with a little circle on it and the y-intercept. So with this question, don't worry about the roots, you're just asked to find the turning point and the y-intercept. On the next one, you've got to find y-intercept and roots, but no turning point, and so on. Okay, choose one or two of those to have a go at now, and I'll put the answers up so you can check your work. If you're feeling confident, skip to the bottom row and test yourself on some trickier questions. Right, have a go. Okay, finish the question you're on, and I'm going to put some answers up. All right, answers coming up. There are the coordinates that we should have found. Check your work there. Any questions, do let me know in the chat box and I'll try and explain it there for you. Some that might have been tricky, this one down here, if that's in your bracket, just like when you're solving, that becomes -1 rather than a +1, but we have to divide it by 2 because there were 2x. So that's why our x value for our turning point is -1/2. Okay, so flip the sign, we get -1, divide it by 2 because there were 2 x's. All right, super, good work there. Now with these ones, just try question 1 and 4 from me. So I'd like you to go the other way. So I'm giving you the graph and I'd like you to write the equation. Now it says in expanded form, that means not just in completed the square form. We want like the original equation, something x squared plus something x plus something. Try question 1 and question 4 because they're slightly different. If you have time, try some of the rest, but I'm just giving you a minute or so. Question 1 and question 4. All right, finish the bit you're doing. And answers coming up. So those are your equations we should have had. For question 1, it's x squared minus 8x plus 15. And question 4, x squared minus 4x plus 2. I'm just going to go through those two and check you're happy with how we get it. So here, we've given very clearly on this graph the roots. So we've got a root there and a root there. Now if our root was +3 and +5, that means our brackets must have been -3 and -5. Okay, so I'm working backwards and finding out what those root brackets would have been. Expand that, you get x squared minus 3x minus 5x plus 15, which when you simplify it, you get x squared minus 8x plus 15. You could have also done that from completing the square because we've got a really nice turning point there. So we could have done that and completed the square format. I'm going to go through the completed the square format with this one. Because if you have a look at question 4, can you see the roots aren't clear? It's 3 point something, but my scale isn't good enough for me to know what it is. But this goes exactly through 2 minus 2. Now that means my completed the square must have been, remember in the brackets it would have been flipped, so it's not +2, that's going to be a -2 for my x squared. And then my y value we keep the same, so that will just be -2 as well. So that would have been my equation. If you expand that double bracket, we would get, I'm just going to do it up here, x squared minus 2x minus 2x, so that was -4x. And then -2 squared is +4. Now we've got our -2 on the end, and when you simplify that, we get x squared minus 4x plus 2. Okay, so that's showing that you can go back from your knowledge of how we get the roots and how we get the turning point, you can work backwards to find equations as well. Okay, fantastic. That's all we're going to do today. I'm just going to walk you through some extra practice questions we've got, and you can pause if you're watching this after I've done the session and work through them in your own time. Do stay listening for a minute because I've got some details about the next session at the end here. So this worksheet is practice just for solving by completing the square. So So that was the first box when you set it equal to 0, and then you have to remember the plus minus and the square root. The questions start off simple, but they get trickier. You have to rearrange first to make them equal 0. Some of them we've got multiple x squared numbers. Some of them you've got brackets, so you've got to expand first and then simplify. Okay, so that's a good practice. Answers coming up now. All right, answers are up. Pause if you need to mark your work. The next practice exercise I've got for you is this grid taken from Craig Barton. This one is for basic practice, so if you want just all the things together but not too tricky completing the square, nice simple equations. So for example, in the top one they've given you the raw equation. You've got to find the roots version, you've got to find the completed square version, you've then got to find the x-intercept, y-intercept, turning point and sketch it. In the others they've given you kind of one bit and you've got to work backwards to find the others. So that's the basic version. There is also a challenge version, so that's what I'm on now. It's just slightly more difficult questions, so you can see we've got a negative popping up in question 13 there. Okay, pause and have a go. Answers are going to come up in a second. These are the answers for the basic practice, so once you've had a go, see which bits you got correct. And these are the answers for your challenge questions, so pause it to mark if you've done those. Okay, that was a lot of resources today and a lot of tricky maths there with completing the square. I hope you followed and it helped you understand it a little bit. Please do give this video a like or subscribe to my YouTube channel or like my Facebook page and try and spread the word there so that I can help some more Year 10s as well who are feeling maybe a bit anxious about being prepared for Year 11. You can download this PowerPoint with all my notes on it from my website, mrsk'slightbulbmoments.wordpress.com. If you want even more practice questions, you can find them on Corbett Maths, and there's other videos there of him explaining it. The next session will be this Wednesday, so in 2 days' time, Wednesday the 10th at 5 p.m, both on YouTube and Facebook. And we'll be doing our last session on quadratics, looking at pulling everything together with quadratic graphs. A bit of some extension questions as well. It's a nice meaty lesson to be getting on with. All right, I will see you on Wednesday. Well done today.